Assalamualaikum and good morning to Encik Afian and fellow friend. This presentation is for the course Mtes 3232 Curriculum Study and Learning Theory in Primary School Mathematics. For task 1 presentation, we are required to design a mathematics lesson and demonstrates how learning theories can be applied in actual classroom teaching. Allow us to introduce ourselves. My name is Nur Najla Akila binti Nazardin and this is my partner.
My name is Anis Hanani binti Muhammad Firdaus.
In this presentation, we will demonstrate how learning theory can be applied in designing a meaningful mathematics lesson, particularly for the topic of perimeter for Year 4 pupils.
We will also show how our lesson design supports pupil conceptual understanding through hands-on learning activities.
So, we move to the next slides. These slides show the application of learning theory in designing mathematics instruction.
In this lesson, we apply Piaget's theory through the use of concrete furniture models to help Year 4 pupils understand perimeter through hands-on learning.
We also apply constructivist theory when pupils explore the furniture layout and discover how perimeter represents the total boundary of a shape.
Through this activity, pupils develop conceptual understanding rather than just memorizing formulas.
Next, I will explain the importance of meaningful learning in primary mathematics education. Meaningful mathematics learning is important because it promotes conceptual understanding. This means people understand the concept of perimeter as the total boundary of a shape instead of just memorizing the formula. It also connects mathematics to real-life situation. In this lesson, we use a furniture floor plan so people can relate perimeter to how objects are arranged in a real room environment. Besides that, meaningful learning encourages active engagement. Pupils are not just listening but actively involved in arranging furniture shapes, identifying size, measuring lengths, and calculating perimeter. Meaningful learning also supports conceptual understanding rather than procedural memorization. Pupils first explore and measure the shape before calculating the perimeter, so they understand the concept before applying the formula. In addition, meaningful learning supports constructivist learning through exploration because people develop understand through hands-on experience and guided discovery. Now, we look at the application in this lesson. First, this lesson uses a hands-on perimeter activity using a furniture floor plan layout, which allows people to learn through concrete experience. Second, the lesson uses 2D furniture manipulative to help pupils visualize the shape clearly and support learning at the concrete level. Third, the activity promotes collaborative learning through spatial arrangement tasks, where people explore how different layouts affect the perimeter. Finally, pupils explore perimeter through spatial layout design, which help them concrete geometry concept with a real-life space organization. Overall, this lesson shows how meaningful learnings makes mathematics more engaged, practical, and conceptually understandable for pupils. Next, I will explain how this lesson is aligned with the KSSR Mathematics Curriculum Standard. This lesson is under the learning area of measurement and geometry, which focus on develop people understanding of measurement, concept, and geometric properties. The topic selected is perimeter, which is part of the Year 4 mathematics syllabus. This topic helps pupils understand how to determine the total boundary length of 2D shapes. Based on the content standard, people are required to determine the perimeter of polygon. In this lesson, people achieve this through measuring and edit the side length of furniture shapes. Based on the learning standard, pupils must determine the perimeter of polygon given the side lengths. This is achieved through the activity where people measure the furniture shapes using grid unit before calculating the total perimeter. This lesson is suitable for Year 4 papers because they are in period concrete operational stage where they learn best through concrete material and visual representation. Therefore, the use of furniture manipulative supports their cognitive development and strengthens their conceptual understanding. Next, the intended learning outcome of this lesson are clearly defined. First, people will be able to identify 2D shapes forming furniture in a room layout, which help them connect geometry concept with a real-life object. Second, people will be able to measure the size of furniture shape using grid units, which develop their measurement skill. Third, people will be able to accurately calculate the perimeter furniture shape, which directly achieve the main learning objective of the lesson. Fourth, people will be able to apply perimeter concept to solve real-life spatial problems such as determine the boundary of object in a room layout. Finally, people will be able to justify their perimeter calculation using mathematical reasoning, which encourage people to explain their thinking and not just provide the answer. Overall, this lesson demonstrates strong alignment between curriculum standard, learning objective, learning theory, and classroom activity, ensuring effective and meaningful learning.
Next, we explain the educational significance of learning perimeter in primary mathematics. Learning perimeter is important because it develops pupils' measurement and spatial reasoning skills. It also helps people to understand the boundaries of shapes and how the outer edges form the total perimeter. Besides that, learning perimeter connects mathematics with real-life situations, especially through activities like room layout planning. It develops spatial visualization and logical reasoning skills as pupils need to analyze shapes and determine which size to measure. In terms of relevance, pupils can relate perimeter to objects around them and learn through concrete experience, which is suitable for pupils in the concrete operational stage. From a pedagogical perspective, this lesson promotes conceptual understanding, encourages problem solving, support meaningful mathematics learning, and help pupils to understand perimeter through a real-life room planning activities. Next, we move to the pedagogical justification based on Piaget's theory. This activity aligns with Piaget's theory because pupils manipulate 2D furniture models before calculating perimeter, which support learning through concrete experience. The activity also matches the concrete operational stage where people learn through manipulation and logical reasoning. The learning process follows the concrete, pictorial, and abstract progressions, where people first arrange the furniture layout, then identify the shapes, measure the furniture boundaries, and finally calculate the perimeter numerically. This ensures pupils to understand perimeter conceptually before applying formula.
Next, I will explain the pedagogical justification based on constructivist theory. This activity reflects constructivist principle because people actively construct knowledge through exploration rather than receive information passively. In this lesson, people discover furniture shape independently, which encourage active learning. They also solve perimeter problem collaboratively, allowing them to share ideas and learn through discussion. Besides that, people explain their perimeter calculation, which help develop mathematical reasoning. They also design their own furniture layout, which allow them to apply perimeter concept creatively. Through this process, people are able to construct their own understanding of perimeter through experience and exploration. In this lesson, the teacher acts as a facilitator rather than a knowledge transmitter, guiding people through questionings and support instead of direct instruction. This promotes meaningful understanding through active participation, which is the main goal of constructivist learning.
Next, we move to the implementation phase, which is learning activity procedures.
Now, we will demonstrate how this activity will be implemented in a real classroom to show how the learning theories support the lesson.
Today, we are going to learn about perimeter using a furniture layout. Look at this room. What furniture can you see?
I can see a table and a bed, teacher.
Good. What shape do you see from this furniture?
The shape is rectangle.
Very good. Now, if we want to know the total length around this table, what should we measure?
I think the size.
Correct, Najla. The total length around a shape is called perimeter. Today, we will learn how to calculate perimeter using this furniture layout.
Now, I will give you a grid mapper and furniture models. Please arrange the furniture on the grid.
Okay, teacher. I will arrange the furniture first.
Alright.
Teacher, I'm done.
Excellent. So, I want to ask you something. What shape is this bed?
This bed is rectangle, teacher.
Excellent. So, I want to ask you another question. How many sides does the rectangle have?
Rectangle have 4 sides, teacher.
Good. Now, identify another furniture shape.
This sofa is square, teacher, and also this table.
How do you know?
Because all sides are equal.
Excellent.
Now, we are going to measure the sides using the grid. Count the grid units along one side.
Okay, teacher, I will start count now. 1, 2, 3, 4, 5, 6.
So, how many units?
We have 6 units in these sides, teacher.
Good. Now, how many sides does the sofa have?
1, 2, 3, 4. This sofa have 4 sides, teacher.
So, how can we find the perimeter?
We need to add all the sides.
Correct, Najla. So, let us calculate.
7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
So, what is the perimeter?
24 units, teacher.
Good job. Very good, Najla.
Now, how did you get the answer?
I added all the sides, teacher.
So, why must we add all the sides?
Because perimeter is the total boundary, teacher.
Good. Excellent reasoning, Najla.
Thank you, teacher.
Right, Najla. Now tell me, what is perimeter?
Perimeter is the total length around a shape, teacher.
Very good. So, we can conclude that today you learned about perimeter by arranging all the features, measuring size, and calculating the total boundary. So, this shows that the perimeter is not just a formula, but something we can understand through real-life objects. So, I want to ask you one last question. Why do we measure all sides?
It because to find the total boundary.
Very good, Najla. Now you get it.
Thank you, teacher.
So, we move to the next slides. This activity is aligned with Piaget cognitive development theory, particularly the concrete operational stage involving people aged 7 to 11 years old. At this stage, people learn the best through the manipulation of concrete materials, and their logical reasoning developed through hands-on experience. Piaget also explained that learning progress from concrete experience to abstract understanding, and this match year 4 pupils who are in this stage. This alignment can be clearly seen in our activity. First, pupils construct room layout using 2D furniture model, which represent concrete learning because they physically manipulate the materials. Next, pupils identify the 2D shapes from the furniture layout, which help them understand the structure of the shapes. Then, pupils measure the side before calculating the perimeter, so they understand the boundary concept before using mathematical procedure. Through this process, pupils move from furniture exploration to perimeter calculation, showing the transition from concrete learning to abstract mathematical understanding as suggested by Piaget. From a pedagogical perspective, this activity supports pupils' conceptual understanding of perimeter because they understand the meaning before calculating. It also promotes active learning through experience since people actively explore and measure rather than just listen. Finally, this activity ensures learning is appropriate to pupil cognitive level because the task match how people in the concrete operational stage think and learn. Therefore, this activity clearly support pupil cognitive development because they learn through concrete manipulative before progress to abstract perimeter calculation, which strong aligns with Piaget theory.
Next, we will explain the pedagogical justification based on constructivist learning theory. Constructivist learning emphasizes that pupils actively construct knowledge through experience, exploration, and interaction. In this activity, pupils explore perimeter by arranging furniture layouts, working collaboratively, and discussing perimeter calculations. Pupils also explain their mathematical reasoning and design their own room layouts which support active learning. From a pedagogical perspective, this promotes active participation, encourages collaborative learning, and develops meaningful understanding of perimeter. Therefore, this activity supports constructivist learning because pupils construct their understanding through exploration, discussion, and collaboration. Next, we move to the slide the anticipated learning outcomes. In terms of mathematical understanding, pupils understand perimeter as total boundary length, develop mathematical reasoning, and justify their perimeter calculations. In terms of skill development, pupils develop measurement, reasoning, and problem-solving skills. In terms of engagement, the activity promotes active participation, collaboration, and motivation in learning mathematics. Finally, in terms of assessment evidence, pupils' understanding can be observed through worksheet calculations, teacher observation, and pupil explanation during discussion. Overall, these outcomes show that the lesson supports understanding, skill development, engagement, and assessment. This activity also supports the development of 21st century skills among pupils. In terms of critical thinking, people analyze the furniture shape and determine the perimeter. This also develops their problem-solving skills as they need to decide how to measure and calculate accurately. For creativity, people design their own furniture layout, which allow them to think creatively while applying mathematical concept. In terms of communication, people explain their perimeter reasoning during discussion, which help them justify their mathematical thinking. This activity also develops character, as people practice responsibility when sharing materials. This also demonstrates the integration of KPPP competencies such as responsibility and positive learning attitudes.
Finally, the activity promotes collaboration because people work cooperatively in group to complete the task. Therefore, this activity not only develops mathematical understanding but also support important 21st century competency need for holistic people development. This show the activity integrate both academic learning and soft skill development.
Next, we move to the instructional challenges and reflective teaching practices in this lesson. The first challenge is that some people may be confused in identifying the parameter of furniture shapes. To address this, the teacher provides scaffolding through guided questioning, such as asking people which side form the boundary and how to add the length correctly. The second challenge is time limitation during the activity. To manage this, the teacher provides structured instructions so people can complete the task more efficiently and stay focused on the learning objective. Finally, in terms of the benefits or impact, people may have different levels of understanding. Therefore, the teacher provides different support. Finally, in terms of the benefits or impact, the pupil may have different levels of understanding. Therefore, the teacher provides different support to ensure all people can participate and understand the concept. Overall, these reflective practices help improve teaching effectiveness and support pupils' understanding of parameter.
So, the next slide is conclusion. In conclusion, this activity demonstrates how learning theories can support meaningful mathematics learning. From Piaget perspective, the use of concrete materials such as the 2D furniture model helps people develop conceptual understanding because they learn through manipulation before moving to abstract parameter calculation. From the constructivist perspective, the activity promotes learning through exploration and collaboration, where people actively arrange furniture, discuss answers, and construct their own understanding. This shows how the activity transforms parameter from procedural learning into conceptual understanding because people understand the meaning of parameter before apply formula. In addition, the activity connects mathematics to real-life spatial planning since people relate parameter to room layout design. Finally, this lesson reflects learner-centered teaching practice where people actively participate while the teacher acts as a facilitator. Therefore, this activity shows how effective lesson design can integrate learning theory, real-life application, and active learning to develop meaningful mathematical understanding. This show can effective mathematics teaching is not only about content but about how learning is designed based on how people think and learn. So we move to the next slides. The next slide is references. These are the references used to support the theoretical and pedagogical justification of this lesson, including source on Piaget theory, constructivist learning, CPA approach, and KSSR curriculum standard. Thank you for your attention. We hope this presentation has shown how learning theories such as Piaget and constructivists can support meaningful mathematical learnings, especially in teaching parameter. That is all from us. Thank you.